Hi, welcome back to Common Core Algebra II. Today's notes are on 8.3, which is basically more practice with exponents. So I put this exponent law sheet on the front of your page so you could spend a little time and just remind yourselves how to manipulate exponents. Okay, I'm not going to spend time going over it. You might just want to take a minute and just remind yourself how these laws work. So we're going to do lots of simplifying today. Today says exercise 1 says simplify each of the following expressions. Leave no negative exponents in your answer. So the first one, using our laws of exponents, when you have the same base, you keep the base, you add the exponents. Over here in the denominator, you have the same base, you multiply the exponents when they're right next to each other. So this would be equal to 1 over x to the third power. Or if you use your other law where you subtracted them, you get x to the negative third power. So because it says don't use negative exponents, this will be our answer. So in B, because we have this raised to the fourth power up here in the numerator, you're going to have x to the 2 times 4, which is to x to the 8th, y to the 1 times 4, which is 4, divided by x to the 5th, y to the 7th. And now we know we subtract our exponents. So we get 8 minus 5, which is 3. We get 4 minus 7, which is negative 3, which of course they say no negative exponents. So that means we're going to drop that down to the denominator. So you're going to get x to the third over y to the third. All right, this one looks a little scary, but just follow the rules. When you have the same base, you subtract the exponents, right? So x, so I'm going to do negative 2 minus a negative 6. Watch those signs. All right, so negative 2 minus a negative 6, and y is going to be 4 minus, and this is a 1. So negative 2 minus a negative 6 is negative 2 plus 6. So this is x to the 4th, y to the 3rd. So that wasn't quite as bad as we thought it was going to be. So how about this one? Let's see. The first thing we're going to do is multiply them out. So we have x to the negative 3 times 2 is negative 6. Y to the negative 4 times 2, which is negative 8, divided by, remember there's a 1 here, don't forget that, x to the negative 4, y to the negative 12. Multiply them out. And now we're going to use our rule where we keep the base and we subtract the exponents. So we're going to have x to the negative 6 minus a negative 4, y to the negative 8 minus a negative 12. Now, you don't have to do that out the way that I did. I just want to show you where numbers come from. So x, when you do negative 6 plus 4, you get negative 2. You do y negative 8 plus 12, and you get y to the 4th. But no negative exponents, so the y to the 4th is allowed to stay up in the top, where x squared has to go downstairs. Again, these are a little tricky. You might need a little bit of time to, understand and remind yourself how to look at exponents. So in exercise 2, maybe I want you to try some of them on your own before you let me come in and show you the solutions. Did I miss 2? There it is. All right, so why don't you give it a try? I know they're fractions. I know you're going to get flipped out by them, but why don't you give it a try? I mean, having the calculator is usually an easier thing with fractions, but I know you can do it. Okay, here we go. So in our numerator, we have the same base, so we're going to keep the base and we're going to add the exponents. So 1/3 plus 1/2, again, calculator is easier here, but 1/3 plus 1/2, you need a common denominator. So 1/3 is the same thing as 2/6. 1/2 is the same thing as 3/6. So adding them together, you get 5/6 over x to the 1/6. So when you have the same base, we keep the base and we subtract the exponents. So this is easy enough to do. 5/6 minus 1/6 is x to the 4/6, which we can reduce to x to the 2/3. Like I said, using a calculator for fractions is a little more easier, a little easier to do than, I was trying to find a way of saying it was less stressful. But I'm here with you for these. So, and tomorrow when you do them in class, you'll have your handy dandy calculator. So in your numerator here, we're going to multiply them. So simply x 1/2 times 5 is x to the 5/2 over, and now we're going to add these. So 3/2, which is really 1/2. You can even add them that way if you wanted to, but you get 3/2 plus 3 is equal to x to the 9/2. And then again, we can do this using our calculators. So it's x5/2 minus 9/2, which is equal to x to the negative 4/2, which is equal to x to the negative 2. Of course, we're not allowed to leave it that way, so it's 1 over x squared. And our last one. Now, this is what I was saying. Beware when you have numbers, like when you have this 4 that's sitting right over here. Remember, that really has a little secret 1 exponent to it. So when you do the multiplying here, this is really going to be 4 to the 3rd power times x to the 2/3 times 3. So make sure you multiply that 3 by everything inside those parentheses. So, of course, 4 to the 3rd power is 64. And then x, when you do 2/3 times 3, you get x squared divided by 32 x to the 8th. So that's easy enough to do. So 64 divided by 32 is simply 2 x, and when you do 2 minus 8, you get 2x to the negative 6. So it means the 2 actually has a 1, so that is allowed to stay up in the numerator, and that x to the 6 excuse me, drops into the denominator. Write down what you need to, and let's go on to exercise 3. Okay, now you thought you were confused before? Just wait. So, when you do these, x to the 5/3. So what does that mean? It means this is, remember, the top is the power, the bottom is the root. So there's two ways that we can write this. You can write this as the 3rd root of x to the 5th, or you can write it as the 3rd root of x to the 5th power. It doesn't matter which way. But what we have to do here is we have to break this up. So I'm going to write it the first way and not necessarily the second way, because I can simplify this some more. I can do that by saying, well, I have a 3rd root here. All right? So I'm just trying to get that cursor to move. It won't move. It's staying there. Doesn't want to move. Let's see if I can do this and move it down here. Nope, it's still up there. How about we do that? Okay. So, oh, it's still there. I'm trying to get it to move away and it won't. So, let's just leave it. How about we do this? So we have 3x to the 5th power. Now, we're going to rationalize this because we have cube root. So any multiple of 3 will actually be a perfect cube, and we'll be able to pull that out. So what I'm saying is I have the cube root of x to the third power, but what do I have left over? I have two x's left, right? So now the cube root of x to the third is x, and we have to keep the cube root of x squared over on this side. Okay? We're rationalizing. I know it's been a while, but that's what we need to be doing here. So let's take a look at this second one. First, I know the fractions, they make everyone nuts. So the first thing you do is subtract them. You do x to the 5 over 2 minus 4 over 3 right in that calculator, and you get x to the 7 over 6. So what does that mean? It means this is the 6th root of x to the 7th power. So again, we can pull this out. We can make this x to the 6, so powers of 6, so 6, 12, 18. And then what do we have left over? We have an x left over. So there's going to be an x here, 6th root of x. Well, this one's negative already. So this is going to be x to the 3 halves. Just bring it up to the numerator, right? So what does this mean? This means this is the square root of x to the third power. So I can break this up, again, powers of 2 now. The 2 is hiding there, but there really is a 2 there. So we're going to pull out an x squared with an x left over. The square root of x squared is simply x root x. Okay, if I haven't blown your mind yet, we're moving on. So let's look at D. All right, D says we have, let's do some subtracting first here, right? So we have x to the third divided by x to the 1/2, which is the same thing as, so we do our subtraction, and we get x to the 5 halves. So what that means is it's going to be the square root of x to the 5th, and we're going to pull out even power. So I can pull out x to the 4th. I can pull out, I have an x left over. So when we take 4 and divide it by our square root of 2, we get x squared, square root of x. Just in case. Make it a little bit easier to see. So let's multiply first. So remember what this means. We have to take 8 and raise it to the 2/3, and take x and do 5 times 2/3. So you can do that math out in your calculator, and you come out with 4x to the 10/3. All right, so now what does that mean? Let's just slide this up a little bit. That means I keep the 4 on the outside. That means I have a cube root of x to the 10th power. So we're going to keep the 4 on the outside, and we're going to break it up into, remember when I called it the perfect squares and I don't cares? All right, so the perfect squares, multiples of 3, so I can take out 9. But then it gives me an x left over. So now 9 divided by 3 is going to be 3, so I'm going to have 4x cubed, and then the cube root of x. Be careful how you write that. Sometimes the 3's kind of get mixed up together. And the last problem. Okay, we're going to do the same thing. We're going to multiply this out. So this is equal to 27 to the 1/3 times x to the 1/3 over 6x to the 1/2. So we're going to do some, so 27 to the 1/3 is simply going to be 3. So this is 3x to the 1/3 divided by 6x to the 1/2, which is equal to 1 over 2 x 1/3 minus 1/2, which becomes 1/3, 1/2, I'm sorry, x to the negative 1 over 6. Do it in your calculator. I know you don't have it here, but tomorrow when you come to class, you will do it in your calculator. So what that negative means is that actually that x is going to join the 2 down here, right? And it's going to be the 6th root of x. That's a dead 6, but it's a 6. Nothing else to do with that one. So write down what you need to, and then we have just 2 quick short ones to look at, and then we're done. Okay, so these are our multiple choice questions. The first one says, which of the following is equivalent to 3 rad 8x to the 7th power? So we're just going to do some simplifying. So what does this mean? We're going to rationalize this because there's nothing else to do here. So we're going to try to rationalize it into a perfect cube and what's ever left over. Now, remember what your perfect cubes are. Sometimes you have to take a minute to think about it. 2 cubed is equal to 8. Well, there it is, right? 3 cubed is equal to 27. So I know the 8 is a perfect cube. That can be here. And then I can take out multiples of 3, so I can take out x to the 6th. But that leaves me here with no number but an x. So what is the cube root of 8x to the 6th power? Well, we know that the cube root of 8 is 2. And then 6 divided by our 3 is 2. So 2x squared, square root of x. So I don't see that anywhere. That was basically the way I thought it should be done, but I don't see it here. So let's go back and think about it a different way. So let's multiply it out. Okay. See, even teachers do things wrong the first time around. So what do we get? We get 8x to the 7th to the 1/3 power, right? So we just said the 1/3 power of 8 is 2x to the 7/3. Is that really what they wanted you to do? That was crazy easier than the last one that I did. Okay? So sometimes looking at your answer choices is really a good idea. So the expression 1/4x is the same as, let's see, what is this going to be? This is going to be 1 over, well, the square root of 4 is 2, and then I still have the square root of x left here, but I don't see that here anywhere. So square root of x is the same thing as 1/2 x to the negative 1/2, right? If we bring it up on top, do we see that one? 1/2, here it is right here. All right. So it's just about manipulation. And sometimes with those multiple choices, you start doing work and then you realize that you kind of took the wrong path. And that happens. You just have to go back and start it again and see where they wanted you to go with that. Okay? So we're at 18 minutes, not too bad. I've been trying to keep them under 20, under 15 to 20 minutes. So until next time, make good choices and have a good snow day tomorrow. Bye.